This formula is the trapezium rule, and it's given on the formula sheet, so you don't need to remember it. The trapezium rule is an estimate of the area under the curve. If you want the exact, then that's what we use the integration for. So the h in the formula is found by taking the lower limit away from the upper limit and dividing it by n. So what is n? N is the number of strips or trapeziums that we break up the shape into. I'll demonstrate that in a minute. So h therefore becomes the width of each trapezium in our diagram. Now, the more strips you do, the more accurate you're going to have an estimate. And sometimes they might ask you to work out how close your estimate is. And then this will be in terms of the percentage error. So you may actually have to do the integration to get the exact form. So it'll be the exact minus your estimate divided by the exact, then multiply all of that by 100 to get the percentage form. Okay, so when you're doing your estimate, you might end up with an underestimate or an overestimate. If it's a curve that goes like this, then it will be an underestimate. And if the curve is this way round, then you'll end up with an overestimate. So now we're just going to have a look at how this trapezium rule works. So the yellowy goldy line is our curve there at the top, and you can see what we're doing on this diagram. So we're splitting this shape up into trapeziums. That's the blue shapes that you can see there. So in terms of our formula that we've used previously, A would be here and B would be here, and then that gets split up into however many strips we use, but each one of these strips will be h wide. In order to show how this formula comes about, we're going to talk about the lengths and the heights here. So we're going to call this first one y0. So the length of this next line here would be y1, and this would be y2. And then this one at the end would be yn, and this one would be yn minus 1, where n, remember, is the number of strips that we've got all together. So if we were to work out the area under this curve between A and B, we need to effectively work out the area of each one of these trapeziums. So let's look at the first trapezium here. So remember, the area of a trapezium is a half times the top and the bottom, which in our case will be y0 plus y1, times by the perpendicular distance between them, which is h. And so we've got, for this first one, we've got h over 2 y0 plus y1. So that's the area of the first one. So now let's look at the area of the second one. So that will also be h over 2 because it's got the same width to it, but this time it will be y1 plus y2. And if we take that down here, so here's our, if you like, our nth one that we've got here. So we'll have the area of the nth one is going to be h over 2, and that will be yn minus 1 plus n. So what you'll see happening here, if we were to add all of these, including the ones that are in between here together, is that we're going to be adding some things in twice. So we can see it here with this y1. So our total area is going to be h over 2, because that's the same all the way through. And you'd have y0 plus y1 from the first area, plus y1 plus y2 from the second area, and then the third area would be y2 plus y3, and so on. And then finally we've got yn minus 2 plus yn minus 1, and then the last one would be yn minus 1 plus yn. So what you can see is that all of these y values are doubled except the first one and the last one. So that's why the formula is a half of the h, and then we want the y0 plus the yn. We only want one of those, but we want 2 of everything else. And so that's where the trapezium rule comes from. It is literally adding up a whole bunch of trapeziums that are under the curve to use that as an approximation to the area under that curve. So for this example, we've got y equals x cos x, and we're limited, so our a is 0 and our b is pi over 2, and we've been asked to use n as 6. So n, remember, is the number of strips. So we're going to start with 0, we're going to end with pi over 2. Now to get 6 strips, we're actually going to have 7 lines. Think about it and it will make sense. So we've got to work out what h is, i.e. the width of each of these strips. So remember, h is b minus a over n. So in our case, that's pi over 2 minus nothing all over 6, which gives us pi over 12. So after the naught, the next one along will be h difference, which is pi over 12. Then another pi over 12 gives us 2 pi over 12, which is actually pi over 6. 3 pi over 12, which will be pi over 4. 4 pi over 12, which is pi over 3, and 5 pi over 12. 6 pi over 12 obviously is this pi over 2. So then what you need to do is substitute all those x values into the equation that we've been given up here for y to find out what values you get. So we get 0 here, and then we get 0.2529 here, and 0.4534, 0.5554, 0.5236, 0.3388, and another 0. So now we're just going to use the trapezium rule. So remember, it's h over 2 y0 plus yn plus 2 times all the other y's. Okay, so our h here is pi over 12, and if we divide that by 2, we're going to get pi over 24. And then in brackets, so our y0 is here, and that's 0, and our yn is here, and that's also 0. So plus 2, and then what we need is all these other values. So we've got 0.2529 plus 0.4534 plus 0.5554 plus 0.5236 plus 0.3388. Alright, and then if you take all of that, put it into the calculator, you'll come out with 0.5561 to 4 decimal places.